Hi, Honors Algebra 2. It is Wednesday, May 6th, and we are doing our last section in this probability chapter 15. This section 10 is complicated. The text I find very complicated to read. I read it over every year and find that it is very difficult to understand. So I'm going to go ahead and give you, I hope, a clearer explanation of this material. And I'm also including an extra worksheet because I don't feel like the homework really covers the lesson concepts the way it could. So just know that you're going to have to open up a PDF, and I'll include the answers to it. And then there'll be some other homework from the text as well. So let's go ahead and start talking about first mutually exclusive events. So mutually exclusive events, if we look here at our definition, are events that cannot happen at the same time. You cannot flip a coin and get a heads and a tails at the same time. Those are mutually exclusive events. So here is our formula for mutually exclusive events. And it says the probability of the union of event A and B. Now, union is another word for or. Okay, so just think of that as or. The probability of event A or event B happening, if they're mutually exclusive, you just add the two probabilities together separately. So what's an example of that in real life? Well, it's drawing a king or a queen. You can't draw one card out of a pile of 52 card deck and get both a king and a queen in the same card. They are mutually exclusive events. They cannot happen at the same time. So what we do here is we simply just add the individual probabilities together. So let's go ahead and do that. The probability of getting a king, well, there are 4 kings out of 52 cards in a deck, and there are 4 queens. And so I add the two individual probabilities together, and I get 8 over 52, which when I simplify that is 2/13. And so that's my probability of pulling a card out of a deck and it being a king or a queen. Now let's move on to non-mutually exclusive events. Some people call these inclusive events. The worksheet you have that I have uploaded for you says non-mutually exclusive, but either way you label it. These are events that can happen at the same time. And you're thinking, how is that possible? Well, we're going to look at that in just a second. But let's go ahead and address the formula. The formula is just the same. The probability of A or B, or the union of the two events, is the probability of A plus the probability of B minus the probability of the intersection, that's your upside down U, of A and B. And so this upside down, excuse me, intersection means and the probability of both of them happening at the same time. Okay, now what's an example of that? Well, what if I'm going to draw a card out of the deck and I want the probability of it being a king or a heart? Well, is it possible for a card to be a king and a heart at the same time? Absolutely. The King of Hearts is that card. It is both a king and a heart. So to find the probability of a king or a heart, I do like I did before, the probability of a king plus, now the probability of a heart, there are actually 13 hearts in a deck. There's 13 hearts, 13 clubs, 13 spades, and 13 diamonds. And I'm going to leave a denominator of 52 to make this easy. Now, I have to now subtract the probability of it being both a king and a heart. Well, what is that? There is one card that is the King of Hearts. And why do I have to subtract that out? Well, I have the King of Hearts in this first group, don't I? In my set of 4 kings, one of them is the King of Hearts. I also have the King of Hearts represented in this second fraction. That is a heart that happens to be a king. Well, are there 2 King of Hearts in a deck? No, there are not. And so therefore, I have to subtract one of them out, the overlap. Okay, so let's go ahead now and figure out what we have. We end up with 10 over 52, which reduces to, excuse me, 10 over 52 is 5 over 26. And that's my probability of getting a king or a heart. A king or a heart. Mutually exclusive, non-mutually exclusive. Now, let's talk about this last example. This last example is more complicated. It is a mutually exclusive event, and so we don't have to worry about subtracting the overlap. But let's look at it. From a group of 10 seniors and 8 juniors, 3 students are to be selected at random to form a committee. What is the probability that at least 2 seniors are selected? So I want a group of 3. Well, you should be thinking to yourself, group, I'm going to be using combination here. I'm going to be using combination. Okay. Now, what are my options here? I could first have all of them, probably at least 2 are selected that are seniors. Let's first, the one way we could do that is they could all be seniors. They could all be seniors. Or the other option would be 2 are seniors, right? We're doing at least 2 seniors. Or you could have 2 seniors. Well, if you have 2 seniors, what's the other person going to be? The other person is going to be a junior. Now, I want one or the other to happen. Okay, one or the other to happen. And so let's first of all, this is a combination. We're choosing a general group. So first of all, what is the total number of groups of 3 students that I could pick? Well, there are 8 plus 10. There are 18 students in all. And I want just to pick a group of 3 of them. So that's going to be my denominator. And then if I want them all to be seniors, well, how many ways can I pick a group of 3 seniors? Well, out of 10 seniors, I'm going to choose all 3 to be seniors. Okay. Now, or means now I'm going to add the probability of the second event. The second event. And that is getting 2 seniors. So let's do still 18. Combination, choose 3 as my denominator. And then this time, out of 10 seniors, I'm only going to get a group of 2 of them. And what else am I going to have? 1 junior. So how many juniors could I pick? Well, out of the 8 juniors, I'm going to see how many groups of 1 of those 8 I could have. Now, so I have all seniors or 2 seniors, and I'm going to put here and 1 junior, just so it makes sense, okay? Remember, and means multiply, or means add. Now, let's go ahead here and see what we have. I'm going to go ahead and find my denominator first. I've got 18. I'm going to choose a group of 3. That's 816 ways I can collect 3 groups, a group of 3 out of 18. And then I'm going to do 10, choose 3. I'm going to have 120 different groups of seniors if they're all seniors. And then let's go to 10, choose 2. I'm going to have 45 ways I can have a group of 2 seniors. And I'm going to have, out of 8, I want to pick 1 junior. Well, there's 8 ways to do that. There's 8 people. Now, let's go ahead. I'm going to go under here. And I'm going to do 816. I've got 120 plus. Well, 45 times 8 is 360. I've got 360 plus 120. I've got 480 over 816. And I'm going to go ahead and reduce that fraction. My probability of getting all seniors in the group or 2 seniors and 1 junior would be 10/17. Or means to add the 2 different scenarios together. Let's move on now to something different. We're going to talk about compound events. Compound events are events where more than one event is occurring. More than one event is occurring. And there's 2 types. There's independent and dependent events. You'll be comfortable with this because you've had this before in 7th and 8th grade. Now, an independent event is an event that one event does not affect the others. So if you want to talk about independent events happening, One does not affect the other. Let's use our old example. Instead of the marbles in the bag, we've got buttons in the bag. And I'm going to cross this out because this makes no sense. You're going to have 2 buttons are drawn at random. Now, you're going to draw the first button. Oh, I know what this is supposed to say. The first button is drawn. Okay. The first button, that should say is drawn. Okay. All right. What did I just do? Boom. The first button is drawn. Okay. And I have, okay, is drawn. Okay. The first button is drawn and put back in the bag, and then the second button is drawn. What's the probability of drawing a green and then a blue? Now, this is not like the tulip bulbs yesterday. I'm not reaching down in the bag with one hand and grabbing a group of 2. I'm doing 2 separate events. I'm picking a button out. I'm going to reach out and pick another button out. And my first button is put back. So I want the probability of green, and then my second event is blue. So out of a total of 8 marbles, 4 are green. I'm going to put the marbles, out of the buttons, and then I'm going to put the button back in. So I'm still going to have 8 buttons in the bag, and this time I'm going to pick blue, and I have 4 blue buttons also. So 4/8 times 4/8 is 1/2 times 1/2 is 1/4, and that is my probability of the independent events replacing the button and having 2 draws. Now, dependent events, one event does affect the other event, okay? One effect does affect the other event, and this is the old draw the first button and do not put it back in the bag before the second draw. So once again, I've got the probability of green and blue. Oh, you know what I didn't talk about? Is my formula, okay? When I have more than one event, I want the probability of A and B happening. Remember, intersection means and. You multiply the 2 probabilities. Sorry about that. I missed that little part, but that is your formula for probability when you have compound events. All righty, independent or dependent. Independent or dependent. And sometimes the probability of B is going to change if probability of A has affected it in some way. All right, now let's go ahead and do this one where we're not putting it back. We've got dependent situation here. So the green, we still got 4 greens out of 8 marbles, but we did not put that first green marble back. So I have dependent events. We've got an effect happening. We have a total of 7. And how many blue do I have? Well, I still have 4 blue. There were 4, blue wasn't taken out. So I have 4/8 times 4/7, and what is that going to become? I'm just going to cancel here. I end up with 2/7 as the probability this time because I have dependent events, okay? That 8 is changed to a 7 because I did not replace the button. You know about those. Okay, let's move on to our last definition here is the complement of an event. We've actually talked about this before. The complement of an event is all the outcomes that are not part of the event, okay? An event and its complement together equal all the possible outcomes. So what do I mean by that? Well, the complement of rolling a 6 is not rolling a 6 on a die. The complement of heads is tails. So together, heads and tails make up all the possible outcomes that you can have for that event, okay? Complement of rolling a 6 would be 6 plus not rolling a 6 would be 1 through 5. So you end up with all the possible outcomes. The complement of event A, we go ahead and make the notation is A with a line over it. That means not A. The complement of event A is not A. And the probability of getting an event A or its complement is 1. Okay, think about that. The probability of heads or the probability of tails would be 1/2 plus 1/2 is going to be 1. So I can say then that the probability of A plus the probability of its complement is always going to be 1. Remember, plus means or. So the probability of heads or the probability of tails is simply going to be the probability of the first event plus its complement, and it will be 1. It's a certain to happen. Now, this is a little bit more complex, but it's not bad at all. So don't be discouraged in any way. This is kind of interesting. Let's look at this example. The probability that Ryan will be selected to perform in the band is 3/4. The probability that Faye will be selected is 2/3. And the probability that Joe will be selected is 1/2. Joe is maybe not quite as musically inclined. He has the lowest chance of getting to play in the band. During the tryouts. Find the probabilities of each of the following events. Okay, Ryan and Joe are selected, but Faye is not. Okay, so what do I want here? I want the probability that Ryan and Joe and not Faye are going to be selected. Okay, now I want all 3 to occur. And so I'm going to multiply the individual probabilities together. So I've got Ryan. The probability of Ryan making it is 3/4. And the next event, Joe making it is 1/2. And Faye not making it, okay, is the complement, which will be 1 minus 2/3. Because an event and its complement add up to 1, so the complement of making it is not making it. 1 minus 2/3 is 1/3. And that's it. So let's cancel out our 3's, and we get 1/8. The probability that Ryan, Joe, and not Faye is 1/8. Now, this last one is a little bit trickier. At least one of the 3 is selected. Okay, so let's figure this out. I'm going to write it above since I have more space above. Excuse me. The probability of at least 1, if I add to that the probability of the complement of at least 1, I will get 1 for my final answer. Okay? The probability of an event and its complement is 1. What is the opposite of at least one of these 3 students making it? The opposite of at least 1 making it is nobody making it. So there, when you have at least 1, the complement is none. And trying to find the probability of at least 1 of the 3 would take so much work. You'd have to do the probability at first of just Ryan making it and the other 2 not. Ryan making it and Faye making it and Joe not making it. Ryan not making it, Faye making it, Joe not making it. I mean, there are so many possibilities. It just would be crazy. So this is a really easy way for at least 1 problems to be solved. So since I know that the probability of at least 1, the probability of none equals 1, and that these 2 are complements, I can simply say that at least 1 is the same thing as 1 minus the probability that none of these 3 are going to make it. And that's going to be easy to find. So let's do 1 minus. The probability of none would be, let's start first with not Ryan. Well, Ryan is 3/4. So not Ryan is 1/4. And I would have a not Faye. And we already did that one. Not Faye would be 1 minus 2/3 or 1/3. And then not Joe would still be 1/2, same as Joe making it. Okay, so I've got 1 minus 1 over 24. Well, the probability of at least 1 making it is 1 minus the probability of none of them making it, which is 1/24. And so here we are. The probability that at least one of these guys or ladies is going to make the band is 23/24. That's pretty high. That's very high. High probability, extremely likely. Alrighty, so you'll have an extra worksheet to do with the answers. And I'm giving you the answers for reinforcement. Please don't rely on it too heavily. You may want to check the answers to help you with the first 2 or 3. But, try to do them on your own because, you'll have some quiz and tests coming up. You want to make sure that you can do those independently. Well, have a great Wednesday. I miss you, and I will see you at Zoom, or I'll be back with you on Thursday. Have a great day. Bye-bye.